if it said that it told you the point was the midpoint, so you knew that those two sections were the same. So now you could have done a couple of different things with this one. Oh, no, I'm sorry, this one didn't say midpoint. My bad. I was reading that incorrectly. This one was not the midpoint. This was just your segment addition review, which means those two segments have to add up to equal how much? 18. So you wound up with 2x minus 11, 2x minus 15. You set that equal to 18. Combine your like terms just like we've done in the past. You wind up with 4x minus 26, I believe. And then you're back to the good old, bless you, back to the good old-fashioned two-step equation. With any luck, that means you did and add the 26 over. And it looks like you get 44. And you get 11.
Yeah.
Right. Shouldn't have been anything crazy. Now, the next section said that we wanted you to find the midpoints. So when you're finding midpoints for the next grouping here, for example, we'll do. All right, 7's a little weird. All right, let me show you. 7, it gave you your two endpoints. Was what? 2 and negative 4. Negative 2 and positive 4.
Yep.
And that was for both of them, right?
Yep.
Okay. So if those are your points, isn't that the same point? Yes, sir. Yeah, that's the idea. You didn't have to worry about it. You got the same number, didn't you? Yeah. Because even if you go through the long form of doing all that work, if you did the negative 2 plus negative 2 divided by 2, you get negative 2. That's okay, and that's fine. And those types of mistakes happen. And let's say you did that, but you showed your work, and you accidentally forgot the negative thing. Mrs. Starr and I would have been like, "Oh, she just didn't see the negative." And you knew how to math it. It was just you just didn't know how to read it.
Yeah.
For lack of a better term, it's. I mean, how often does that silly stuff happen? It happens all the time. So yeah, that one works out to be the same value for both of them. But flip it over real quick and let's revisit real quick how do we find the missing endpoints. So remember, if you're doing missing endpoint, if you have one endpoint, can you get just close? We'll do 13. 13 is negative 6 and 8. Negative 6 and 8. Then it has the midpoint at 5 and 5. What's the other endpoint? So one of the things I started doing with, I think it was 9-10, because they were having just a heck of a time visualizing what exactly is happening when you're talking about these, about the numbers and counting. What I want you guys to start thinking of is we're using number lines twice. We're going to use the number line for the x values, and we're going to use the number line for the y values. So if I look at the x values, excuse me, to go from negative 6 to positive 5, do we go up or down? How many? 11, yeah. You went up 11, so I'm going to write plus 11, which means to go from 5 to this value also has to be plus 11. So what's 5 plus 11? Go.
Oh, yeah.
So once you start seeing it, if I write it out with that plus value, some people are starting to see it a little bit cleaner. Okay?
So just think if you're going, are you going up or are you going down?
Yeah. Now from 8 to 5, do you go up or down?
Down.
How many?
3.
So you went down 3 to get to the 5, which means I have to go down 3 again, and that's where you get your 2. You're just a step ahead of me, all right? Remember, that's the easiest way to do this. How far are you counting in terms of the number line? Okay? How far are you counting in terms of the number? I forgot. Well, let's do another one of those real quick. What's the other one? Let's look at 14. We have 0, 6, 8, and 6, I believe. 0, 6, 8, and 6. I don't think I asked you guys to do this one, but it's pretty easy to walk yourself through.
And then 8, and it goes up 8.
Okay, good. So we go up 8, so I'm going to write plus 8.
Yeah. And then you do that again, yeah.
And I have to write,
Plus 8.
and what's 8 plus 8?
8 is 16. And then you put the comma. Yes. You go back to the 6.
Go back to the 6, okay?
And that's the 6.
It's the same, isn't it?
So 0.
So 0 plus 0, or minus 0, plus you, which means what goes there? Counting. It is, usually is, And in a lot of this stuff, guys, we try to make sure that you guys see this in such a way that it makes it so much easier. Because there's no real reason for us to use the formulas for this stuff, because it gets to be really, really muddy. Okay? Were there any other questions as far as, did you want to double check any other missing endpoint ones, or I know we only had a few of those on there. Okay. So on this sheet, there's another section that we did not get to. It's on the back page, and I think it's numbers 15 through 18. Oh, on 19, I think I asked you guys to do that last problem on there. Did you guys do okay on that very last one? It wasn't 19, it was number 21. Were you guys okay on 21? Yeah. Did you okay on that? That one should have been pretty simple because you just had 3 sections right away to the whole thing. Okay. So let's look at this idea of what's called the distance formula. So distance formula I like to look at the distance formula. And I know you guys don't have graph paper, and you don't need graph paper, but I'm going to show you guys a really, really easy way to do distance formula. And again, it's going to relate to counting, okay? So let's look at number 15. Number 15 has the ordered pairs of 1, -6, and what was the other one? -4. -4, -2. Thank you, sir. Okay? And I'm going to do distance formula in relation to those 2 coordinates. Now, there's the long-winded actual real distance formula, but I think there's an easier way to do this. Yes, there is. Right?
Oh yeah, you just take that part there.
Now, here's the thing. And then you're okay with that. You're okay. Here's the thing. Most students can remember this formula. Most students can substitute values in and all that. But one of the things that students tend to always screw up is if you have negative value and you square it. If you're not smart enough, but not to say that you're dumb, but if you're not savvy enough with the calculator, you can make a really dumb mistake, and it happens all the time. So the way that I like to show the distance formula, and I know you like how I do the triangle stuff, it alleviates that issue because we go back again to counting. And I know apparently we've learned how to count by now. It is, we hope. So just for, like I said, you guys don't have graph paper, but I just want to show the first example in terms of what it looks like on a graph, and then we'll walk from there, okay? And then we're at -4, -2. So what we want to do is find the distance between those 2 points. Everybody okay with that? Now, on a graph, do you guys agree that there's always going to be some horizontal component and some vertical component? A left and right, and up and down? So, if I look at that, what kind of a triangle did I just make? A right triangle.
Crazy.
Nah. So, I've made a right triangle, and we all know that in right triangles, you get this thing, a squared plus b squared equals c squared, correct? You guys vaguely remember Pythagorean theorem? So, what we can do here is we can figure out your a and your b, if you want, just by counting. So if I look at this, how far apart is 1 and -4? How far apart is 1 and -4? How far apart are these? How far apart are those? 5, right? They're 5 apart. How far apart is -6 and -2? 4. So if I know that these are 5 apart, and these are 4 apart, all I have to do is 5 squared plus 4 squared will equal are c squared. Because that creates the side lengths of the right triangle. It's an easier way than doing this with all of your negatives, because you can get really mixed up if you've got a lot of negative value. I'm just figuring out how far apart it is. Well, I know from counting how far apart is 1 and -4. It's 5. How far apart is -6 and -2? It's 4. So, on your calculator, what's 5 squared? It's 25. What's 4 squared? So it's 25 plus 16, and I believe you get, what is that, 41? When you add those two together. Now, your calculators, if you have the multi-view calculator.
It's a handy dandy, only $15 if you buy here.
Is it $12.99 at Target now? Buy it at Target and save yourself a
Buy
buck.
it at Target.
You'll probably save yourself a buck in tax.
Right.
And then you just, how do you undo squaring?
You,
Square root.
yeah.
So your answer, if you have the multi-view calculator, would be the square root of 41. If you have the calculators that have the decimals and stuff, no, it doesn't want to show up. Oh, let's use this one. If it gave you a decimal, okay. In this class, whenever we do anything with decimals, what I want you guys to do is always round to 2 decimal places. The 100. We're always going to round to the nearest 100. So if you look at 2 decimal places, that means you always are going to the third number and checking to see if it's a 5 or greater. If it's a 5 or greater, that second number goes up a digit. But if it's 4 or less, that second digit stays the same. Just a quick reminder, it's just kind of how we always do this. Yes, ma'am?
So am I thinking that you can square root and that?
Square root of 41, that's fine.
So if you hit that double arrow.
If you hit the double arrow to get it to you.
It'll change it to a decimal. Oh, okay.
If your calculator gives you your answer in terms of the square root, leave it. That's perfectly fine. That's what we call an exact answer, or a simplified radical form.
Where's that picture from?
That's the Bodie walk-off from last year.
He was like, whoa.
This one's not working. I got to restart it. Yeah, that's such a great picture. I love the one from the picture of it from behind.
Yeah.
Because you see, they hit the back, just go on the. There's like. He knew it was God. Okay. So again, the reason that we like to use this is because it's turning your distance formula into what it really is. The Pythagorean theorem. The distance formula is the Pythagorean theorem. How far apart are your x values? Well, we did that. How far apart are the x's? They're 5. What's 5 squared? 25. How far apart are your y values? -6 and -2. They are 4 apart. That's what that means, the distance between the 2 points. 4 squared is 16. The distance formula is Pythagorean theorem with more work, actually, the way I hope so. Yes, sir. Yes, sir. For this to go through, it has to be. Because if you think about it, you're always going to have some horizontal, an x value to go, and then you have to go up or down the y value. So when you change direction, horizontal and vertical, it's always right angle. Okay. What are the ordered pairs for the next problem, guys, on that worksheet? What is it? 1, -8, and the other one is? 3, -5? Okay. So we're going to do the same thing. We're going to find the distance between these two. So what we do is, we're going to count how far apart are 1 and 3. I know that 1 and 3 are how far apart. They're 2 away. So I know I'm going to have a 2 squared. Okay. And then I do the same thing. How far apart is -8 and -5?
3.
They're 3 apart. So we have 3 squared. Yeah, you're right. Okay. So now I know that the distance between those two is just going to be these two added up and take the square root. So the distance is going to wind up being whatever the c value is. We'll keep writing it in terms of Pythagorean theorem here. So what's 2 squared? What's 3 squared? So you have 4 plus 9, which gets you to 13. Bless you. Which means the distance between those 2 points will wind up being just the square root of 13. And we don't need to worry about a decimal. If your calculator gives you a decimal, it's probably 3.5-ish. That's close.
How do you know?
How do I know? Well,
Do I know?
yeah, teacher bro. So, do you agree that the square root of 13 is between the square root of 9 and the square root of 16? What's the square root of 9? 3. What's the square root of 16? 4. Is it closer to 9 or is it closer to 16? Actually, it is closer to 16, so then halfway would have been like 12 and a half-ish or somewhere. So yeah, 13.6-ish is a good guess. That's how you can approximate your square roots, just by knowing where it lands in between. All right, just find where it lands. Okay, but again, you can leave it as square root of 13. Okay, not too bad.
Yeah.
All right, take a second and do 17 then. Take a second and do 17.
What did they do on paper?
No, you can do on that sheet right there. That's why I had them. I left those blanks so you guys can do them there. If you want to put them in your notes, whatever works. Yeah, 17, please. Use that shortcut. It makes life a lot easier.
You know what? Life is supposed to be hard. I'm saying, all right. They tell me why I had too much fun more.
We can have negative numbers.
All right, let's take a look. From 4 to 2, how far apart are they? They are 2, so I will take 2 squared. Correct. You're just thinking that by getting rid of the negative stuff, by not using the actual formula itself, we don't have to worry about, if I did the actual formula here, it would have been 2 minus the 4 quantity squared plus 1 minus the negative 5 quantity squared. See how this just gets really messy without? Then I'd have negative 2 squared plus 6 squared. You have to be very careful with the calculator by putting parentheses around all the negatives. By doing it this way, we're getting rid of it. Because no matter what, whatever distance you go, distance is always positive. Even if you're walking to the left, you're walking towards negative value, but you're still walking a specific distance. You just move to the left. That's why I don't like to use that. So 2 squared, and then how far apart was negative 5 and positive 1? 6, good. And then 6 squared, so let's see. 2 squared is? 6 squared is? So this is going to be a tough one. 4 plus 36, I'm pretty sure you get 40. And then lastly, what do I have to do to the 40? That's square root. So we take the square root. Now, if you have the multi-view calculator, you probably got 2 root 10. If you did it, you probably got, what, 6 point something-ish?
And if you want the decimal number, when you have 2 root 10 in that calculator, hit that double arrow button.
And the And just like Mrs. Throw and I were saying, it kind of depends.
It's right about the enter.
Yeah, you found your button on that one.
It's right about the enter.
And then we go from there. And the double arrows, oh, you don't have that calculator. She's talking about the multi-view calculator, you have just the regular one. And the multi-view will become, yeah, it really does help out a ton. A lot. It does clean up a lot of stuff. True, but on tests and quizzes, you're going to want to use a calculator. What's that? Thanks, man. I appreciate you encouraging me. Make sure my hands and my arms are strong enough to break through cardboard.
And then take a Sharpie to write on the calculator and on the cover. Your name or something.
I think I have one in here. Hey, do the next one while I'm looking for a Sharpie. Oh, cool, thank you.
218.
218 real fast, guys.
Making sure you get it.
Yes, sir. Which one are you doing? See you in the store. That's when it comes out. Yeah. So let's see. This one here, your ordered pairs were 4, -2, -6, -6. Now, obviously, as you guys can see, each time we have all these ordered pair stuff, we have to be careful to read the instructions of what they're asking us. Some of them said midpoint, some of them said missing endpoint, some of them now say distance. So you have to be careful to know when to do what. How far apart is 4 and -6? Well, those are 10 apart, squared. How far apart is -2 and -6? Those are 4 apart, and I square it. add those two together after squared, you get 116. And then if you take the square root of that, it gives you 2 root 29. Okay? That's fine. Okay? And that's fine. That's absolutely fine. Remember, the calculator, depending upon what calculator you got, it'll give you a specific answer. You said you got 10 point what? So 10.77. Well, that makes total sense because the square root of 116, here's the square root of 100, isn't that's 10, right? 11 squared would be 121. See how it's a lot closer to the 121 than it is the 110, so that means it's got to be more than halfway. Oh, excuse me, it's more than halfway, it's by a bunch. So I would have guessed 10.8 in that neighborhood. It's close enough. All right? That's how we work these things through. Not terrible? Don't need to bore you.
No, I'm not wondering.
It was a long weekend. It was we were just really, really busy all weekend. That's why it seemed like we were just non-stop going. So this evening, I have for us some coordinate, we call it coordinate geometry practice.
Don't move back.
I didn't have much for us to start with today because we didn't get to the. I thought we were collecting. It's surprising. Sometimes I do, sometimes I don't. Some classes I'll collect in 1 day, other classes I won't. Like I might collect 6 7s, or I might collect 9 10s, but I won't collect yours. I keep you guys honest. So it's just a matter of getting through it or not. So what I did here is I kind of went a little overboard as far as the distance formula ones, and those are on the back there. So let's just go up through 12. That means we're just doing 4 of each style. You've got 4 midpoints, you've got 4 missing endpoint, and then you have 4 distance. Sound decent? Honestly, you got what? 20 minutes? Yeah. Just knock yourselves out. Well, not literally.
So all of this
We'll go through 12. Yeah, I put X's wasn't here, but I didn't think we needed Wait a minute. You okay though? Once you get home, you've done all of That's fine. Oh, last year? Yeah, these words together, cut it in half. Okay, you use the formula. There's a formula for the point, so you just add your x coordinates together, cut it in half. Here, you count. -6 to -3, these are whatever. Oh man. Okay, was 3 more than -3? -3 plus 3. Okay. -1 to 0 is what's down. Okay. It's 1 more than 0. That's why we say count. Counting is much easier than trying to math.